All right, welcome. So this is the first video of many for the homework solutions in my Thermo 1 class. If you're out on the interwebs, welcome. If you're one of my students, well, hopefully you get something out of this. So this is the first homework. This is the first problem. This homework is on basic things like properties, phase diagrams, but also molecular interactions and equations of states. So we're following along the book by Milo Koretsky on thermodynamics. So this really is a homework on chapter 1 and chapter 4. So our first problem is consider a system containing water in the following states. What phases are present? Be sure to specify the number of phases, the types of phases, whether it's steam or superheated or whatever. Okay. So really, the only what you want to do on these kinds of problems is go to the steam tables. Okay. So that's always the first thing of a problem. Recognize the problem type. Okay? And so here, okay, this is a steam table problem. It's kind of obvious. So what we need to do, though, is we need to go to the steam tables and figure out where we're at in the steam tables. So when we're looking through the steam tables, the first thing we do is we go to the saturated tables. Okay. Now, luckily, I have the tables scanned into my computer. So what we have, and so first thing you do is go to the saturated tables. Okay, so the saturated temperature tables or the saturated pressure tables. It doesn't really matter which one. Now, why do you want to go to the saturated tables? Well, the saturated is kind of that midpoint. You have subcooled liquids, you have solids, you have superheated vapors, you have saturated liquids, you have saturated vapors. The saturated zone is really the midpoint between all that. So it makes more sense to start looking there and see, okay, do I need to go up towards the vapors or down towards the liquids? Okay, so I always like to look, if temperature is given, I like to look at temperature first. If pressure is given, then pressure, but if both are given, still temperature. So on this first one, okay, so we have temperature 150 degrees Celsius and 1.5 megapascals or 1500 kilopascals. Okay. So what we need to do is go to our steam table, okay, and we're looking for, what was it again? It was 150. Okay, so we're looking for 150 degrees Celsius. So in the back of the book, it is, table B1, saturated water temperature table. Okay, and so I go all the way down to 150. Okay, there it is, and then I look at the pressure. Okay, so now this is the saturation pressure, and remember that the saturation pressure is dependent upon the temperature. Okay, they are not independent variables in this case. So if the temperature is set and it's saturated, then the pressure is set as a result. Okay. And what we're looking for is, okay, is it at this pressure? So pressure here, it says it's 0.4759 megapascals. Go back. Okay, that's obviously not 0.4579. It's 1.5 megapascals. Okay, so I'm not saturated. Now I have to decide, okay, am I liquid, vapor, possible? I don't know. Yeah, it looks like solid's not a choice here. So I'm either liquid or I'm vapor. Okay, and 150 degrees Celsius, probably not a solid anyways. But you never know. Okay, so I look at my pressure. Okay, and I want to decide what? That's right, I want to decide if it's lower or higher. In every case, whether I'm looking at pressure, volume, enthalpy, I'm always looking at, is it higher or lower? Okay? And so, in this case, it's higher. Now I have to ask the question of, okay, it's higher. Is a high pressure a liquid or a high pressure a vapor? That's right. A high pressure equates to a liquid. Okay. And we know it's not saturated. And so the term we use with liquids that are not saturated are subcooled. Okay. So this is a subcooled liquid. Okay. Now, the logic behind that is, again, like at 150 degrees Celsius, the vapor pressure is about 0.5 megapascals, whatever it was. Okay. Because it's above that, I'm a higher pressure than a saturated system. And a higher pressure than a saturated system equates to a subcooled liquid. All right. And that's pretty much what we want to do with all of these. So let's do the next one. Okay. So the first thing we do is we recognize the problem type. Okay, it's a steam table problem. The second thing we do is we go to our saturation table. Okay. So we're at a saturation table. The next thing we look for is our temperature. And the temperature, saw before, and if you need to pause it, that's fine, was 50 degrees Celsius. Okay. So I look for 50 degrees Celsius, and there's my line. Okay. Now, my other variable this time is volume. Okay. So now I'm looking at the volume. Now, you can see in the steam tables I'm given two volumes. Now, what were those two volumes associated with? That's right, the liquid and the vapor of a saturated system. Really, these are the boundaries of that pressure volume curve, or in this kind of case, the temperature volume curve. Okay. But it's, the boundaries of my phase envelope. Okay. So, meaning that, okay, if I'm between these bounds, I'm saturated. If I'm outside these bounds, I'm not saturated. Okay, so let's see if I'm between these bounds. So I got 0.001 and 12. Okay, 1. Well, 1 is definitely bigger than 0.01, and 1 is definitely smaller than 12. So yes, I am in between. Okay. So if I'm in between, what does that mean? It means I'm saturated. Okay. Now, am I a liquid or a vapor? Technically, I'm both, right? If I'm saturated, even if I'm 100% vapor, I still have a minuscule amount of liquid when I'm saturated. Same thing for the liquid. If I'm 100% liquid, I have one bubble that represents vapor. Now that bubble only has 5 molecules, but there's still a vapor. Okay? But it's in between, it's right in the middle. Okay, and so that means I'm a saturated mixture. Now, if I want to ask the question, okay, am I more liquid or vapor? Well, then I look at which number am I closest to? Well, 12 minus 0.01 divided by 2 is kind of about 6. Well, yeah, I'm a lot less than 6, so I'm probably a lot more liquid. Okay, but still, saturated mixture is what I meant. Okay. Now, and where do I come to that? Same thing. I looked at my temperature, I looked at my bounds, and saw that I was within the bounds. Now let's go to the next one. All right, so you have okay, this time I don't have a temperature, I have a pressure. Now, it doesn't matter which table I look at because I'm still looking in between values. Now, yes, there are the tables that have the pressure, but again, I just need to look at the bounds. Okay, so the pressure that I was looking at was, what was it? It was 1 megapascal. All right, so it's not on this one, so I need to go to the next one. Okay, so let's make this a little bit bigger. Okay, so 1 megapascal puts me about, maybe 179 degrees Celsius. Okay, something like that. But I'm not looking at temperature, I'm looking at the volume. Okay, now again, well, this 1 is close enough, so Maybe, so really I'm just kind of averaging these two. I'm interpolating. So the lower end is 0.01124 maybe. And the other one is about 0.2, somewhere in there. Okay. Now, if I'm really close to the boundary, yeah, I should probably go to the pressure table. But I'm not close to the boundary. Okay. I'm 0.4. 0.4 is well above that, and it's above both of those. So if it's above the liquid volume, what does that mean? What does a high volume mean? What takes up more volume? Vapor or liquid? That's right. On a mass basis, a vapor will take up more volume. So in this case, I'm definitively a vapor. Now, when it's not saturated, what's that called? It's called a superheated vapor. Okay. So if you see here, that's a superheated vapor. All right. So we had a subcooled liquid, we had a saturated mixture, and now we have a superheated vapor. Let's look at this last one. 1.5 megapascals and an enthalpy. So we haven't really talked about enthalpy yet, but that's what the H is, so we don't need to know what enthalpy is or anything like that. We're just reading a table. So same thing, let's look for 1.5. Okay, so 1.5, it's pretty much between here, closest to 200. Okay, and then 2,500. Okay, so we look at enthalpy now. Which one's enthalpy? Okay, so it looks like it's these. So we got entropy on the last three, so it's the three before that. So these three right here represent enthalpy. So and again, if we're 1.5 megapascals, we're looking at these ones. And what we're looking for, and we could kind of look at these just to make sure, but what we're looking for is we're looking for 2,500. But there's three numbers. What do these three numbers represent? Well, so the volume had a lower and an upper. What's this middle one? If you notice, the middle one's just a difference. So the middle one is a convenience for other things. We'll talk about it later when we actually talk about enthalpy, but for now we can ignore it. All we care about is the lower and the upper, the liquid and the vapor. Now, is it above the liquid? Okay, yes it is. Is it below the vapor? Yes it is. So if it's between the bounds, it's right, it's saturated. Okay, so it's a saturated mixture. Now, again, so the last one was more of a liquid. Is this one more of a vapor or more of a liquid? Well, it's closer to the vapor, so it's more of a vapor. Okay. How much? Well, that's what quality is for. And of course, that's a different topic. So, to review, we go find the saturation table. We look for either the temperature or the pressure. From there, we look at the second variable to kind of determine the bounds. So the bounds are, okay, are we below the liquid? Are we above the vapor? If it's something that's not pressure, and if it is pressure, is it above the pressure or below the pressure? If it's above the pressure, high pressure means liquid. If it's below the pressure, I'm vapor.